Ontario, a two-part webinar series for SCAN members across Canada. Before we get started, just a quick reminder that this session is being recorded. The session recording will be available on SCAN's YouTube channel before the second session, which will take place on May 5th. Don Booth will give today's land acknowledgement.
Thanks, Mike. This meeting occurs in Toronto on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. These lands are covered by Treaty 13, signed by the Mississaugas of the Credit, and the Williams Treaties, signed with multiple Mississaugas and Chippewa bands. Toronto is now the home of many diverse First Nations, Inuit, and Métis peoples. At this time, it's hard to avoid thinking about what sovereignty means and the weight of Indigenous and settler history. Tecumseh's heroism during the War of 1812 is well known, but his prior pan-Indian activism in opposition to American settler land grabs less so. He believed that the Great Spirit intended that the land was the common property of all the tribes, and that it could not be sold without the consent of all. It seems to me we settlers in Canada owe a great debt which will require us to honor Tecumseh's belief. For a start, we could revisit the meaning of Crown land in that light. Thank you.
Thanks, Don. Many SCAN members know that building heating and cooling is the largest source of greenhouse gas emissions in Toronto, and the second largest in Ontario behind transportation. Most of us are aware of the possibility of using heat pumps to reduce emissions. But there's more to reducing building emissions than the familiar air source heat pumps we see beside some houses. There are reasons to look beyond the heat pumps that most people install. These heat pumps pull heat out of the air, and the colder the air, the harder they work to heat our homes. They run on electricity, and when it's very cold, they demand more and more electricity. Ontario is now meeting increased electrical demand by building gas-fired generators. So, in Ontario, increased demand for electricity means more GHGs from plants like the Portland's plant. Even when additional demand is GHG-free, the cost of building generations is high, and the cost of building transmission lines is often even higher. There are other systems that can keep us warm and cool. There are ground source heat pumps or geothermal under some new apartment buildings, and thermal energy networks, or district heating, providing heating and cooling to a number of buildings at once, such as one finds at many sites across Ontario and indeed across Canada. And we have to be mindful that existing buildings have embodied or upfront greenhouse gas emissions in their construction materials. On a system level, it's more difficult to use ground source heat pumps and thermal networks in existing buildings than new ones. But tearing down existing buildings before their time leads to increased embodied emissions over time. It's a balancing act. We aim in this series to learn more about the way that technologies work and their advantages and disadvantages, and then to piece it together, taking into account both operating and embodied emissions, so that SCAN members can ask thoughtful questions and activists can craft actionable demands of our leaders. We hope that at the end, you will agree with us that each of the technologies have a place in fully decarbonizing our buildings, and getting there will require detailed municipal heating plans to allow us to find the right technology for each place. As SCAN members, we are particularly concerned that heating and cooling be available and accessible to all, that it is a public good. Our first session will be about learning about heat pump technology and thermal energy systems, an introduction to embodied or upfront carbon. There will be a Q&A at the end of today's session using Zoom's Q&A feature. For those who haven't used it before, here's how it works. You can find this feature at the bottom right of your screen under the More section. Please open it now. You will see two tabs, My Questions and All tabs, and All Questions tabs in your Q&A on Zoom. We recommend that you go to All Questions. This will allow you to see any written replies to questions from our Q&A moderator. We encourage people with questions to leave them in the Q&A during the presentations. The Q&A will be visible to our Q&A moderator, but not other audience members. There'll be no chat during the presentation, but we'll turn on the chat at the end of this session to allow those who can stay longer to discuss it if they wish. We begin today with SCAN's own Peter Nicholas, who will present on the way heat pumps work, followed by David MacMillan from the City of Toronto's Forest Environment and Climate Division, who will introduce us to thermal energy networks, also called district heating, as they exist today, and some issues that we will need to address in making them more widespread. SCAN's Gail Fairley will conclude today's program with an introduction to embodied or upfront carbon. Peter Nicholas is a certified engineering technologist and past chapter chair of the London OACET chapter. He was a production and control technologist, an instructor at the Rolfton Nuclear Training Centre, and an agricultural energy advisor for Southwestern Ontario with Ontario Hydro, and an electrical manager and safety manager prior to his retirement in 2019. He's a SCAN member on the Education Committee and the Coordinating Committee. Peter's most recent SCAN blog is Heat Pumps in Layman's Language, and in his spare time, Peter is an energy advisor, a fixer with the London Repair Cafe, and a father and grandfather. Over to you, Peter.
Thank you very much. I'm going to have just a review of the heat pump basics. Thermal energy travels from a warmer surface to a colder surface by conduction, convection, or radiant infrared waves. And the radiant infrared waves come mainly from the sun. If the two surfaces are at the same temperature, then there's no thermal energy going anywhere between the two surfaces. With an air source heat pump, there's an outdoor unit. It's called the evaporator. And here we are on a cooler day, perhaps in the winter, where the outside air is 5 degrees in the red bar, because it is warmer than the evaporator, which has a gas in it that is cooler, and it is minus 10 Fahrenheit. The outdoor unit quite often has a fan, and when they first came out, the neighbors would complain about, what are you running an airport there? And that is the outdoor unit. It sits outside on a cement pad beside the house. Inside the house, in the basement usually, is the heat pump, and the heat pump has a motor in it, and that motor is called the compressor, and that is the heart of the heat pump system. Then inside the house in the basement, there's ductwork and the furnace fan. So the furnace fan would be running, and it would find that it would blow air through an A-frame heat exchanger, which is called the condenser, and it's inside the ductwork. And now the gas that's in the system is now pressurized, and it's 122 degrees Fahrenheit. And inside the house, the air is 70 degrees Fahrenheit, and the thermostat is set at 72, somebody's at the front door holding both doors open, and for the last 20 minutes, they've been saying goodbye to each other and see you later. This is in the winter time. In the summertime, all this goes in the reverse direction, and we take heat from the inside air that's in the ductwork, and we pass that on to the outdoor unit, and that gets passed on to the outside air, and that will give us cooling in the summer. The compressor, again, is the heart of the heat pump. Compressing the gas increases its temperature. Depressurizing the gas decreases its temperature. The gas is called a refrigerant. It's the same stuff usually found in newer refrigerators, same type of system, and the compressor in your refrigerator does the same job as the compressor in a heat pump. The environmentally friendly refrigerant is called R134A. There's the fancy 25-cent word for it, tetrafluoroethane, and it is chlorine-free. CFCs, chlorofluorocarbons, were banned back in the 70s because they eat ionized oxygen, which is ozone. So hot pressurized gas is forced through a small orifice out at the outdoor unit, where it becomes depressurized and cold. The chart for temperature versus pressure for R134A, for example, at 27 pounds per square inch pressure, it would be at 32 degrees Fahrenheit. And if it gets pressurized, say up to 188 pounds per square inch, then it would be at 126 degrees Fahrenheit. And so that's how we get cold going through a heat exchanger and warm going through a heat exchanger. Ground source heat pumps use the same technology as air source. The heat source is below grade, which is usually 45 to 55 degrees Fahrenheit. Plastic pipes filled with glycol, environmentally friendly glycol, are adjacent to or very close to or embedded in sewage systems, district heating systems, lakes, ponds, wells, trench in your backyard with those pipes in it, or boreholes. And you go down 200 feet and have a 400-foot loop of pipe in close contact with all the backfill. Air source heat pumps south of Barrie are 190% efficient on average, and they that means that for every dollar you spend on the motors, the fans, and the compressor, you get $1.90 of heat or cooling into your house. Ground source south of North Bay, for every dollar you spend on the pump, compressor, the fans, etc., you get $3.50 of heat energy into your house or cooling. And so I will thank you very much.
Thank you, Peter, and thank you for that informative introduction to heat pumps. And next up, we have David MacMillan, who will introduce us to various types of thermal energy networks, otherwise known as district energy. David is a manager with the City of Toronto's Environment and Climate Division, where he's focused on planning for low-carbon development and energy systems for nearly 10 years. He works closely with internal partners in the development industry to achieve net zero emissions buildings. And currently, he's focused on delivering mass timber, affordable housing and planning for large-scale renewable thermal energy projects. David holds a master's in environmental studies from York University and is a graduate of the ULI Toronto's Kirtner Urban Leadership Program. Before David begins, a quick reminder that you can record your questions in the Q&A, and our Q&A will occur at the end of all the presentations today. Over to you, David.
Thanks, Michael. Just sharing my screen here. Can you see it? Yeah, perfect. Yeah, thanks again for having me. And as Michael said, I'm going to talk a little bit about district energy systems. So I did this presentation to, I'm sure some of you have seen a version of this prior. I have updated it somewhat, but I will try to go through it quickly. And of course, we'll have time for lots of questions. So again, so district energy systems are nothing new, essentially. They've, in most rudimentary form, been around for 700-800 years. It's really moving hot water through piping. In this case, the world's oldest is in France. But what we're talking about today looks more like what you see on the left, which is insulated pipes that move hot water, chilled water. Legacy systems move steam, but even in some cases now we're going down to even far lower temperatures to enable the integration of renewable energy sources. I think the key takeaway here is that district energy is not it's not a technology, it's a platform. It's much more like infrastructure. Sometimes it's referred to as the third grid, the thermal grid, not electricity, not natural gas. But fundamentally, it's the same type of business model or very similar type, and that's the way that I would suggest thinking about it. But before I go too far into district energy, just some context. Again, you've probably seen versions of this. It is updated with the latest data we have, but the story is the same for Toronto, which is that number one, the vast majority of our emissions are coming from buildings, specifically heating, space heating, and hot water. Over 90% of that is due to the combustion of natural gas. So that's really the target for decarbonization. Of course, a big slice is transportation. Solutions are a little more straightforward, but fundamentally, we're trying to reduce natural gas use. Unfortunately, the latest information shows we're not on target to achieve our net zero goal. Unfortunately, our emissions are going up. Again, this is after, first of all, a major drop due to coal phase out in the 1990s and 2000s. And then it's been a little more volatile. We did see a drop during the initial lockdowns when COVID was prevalent. But we're back in an increasing trajectory, unfortunately, and we're likely not to make our 2025 target without drastic action, and we're definitely not on track for 2040. We also have pretty aggressive energy targets. So we need to get to 50% renewable energy use by 2030. Currently, we're about half of that. And then 25% of floor area in the city should be connected to a low carbon thermal energy source. Again, we're not even close there. We're at less than 5% based on my best estimates. Also, in order to enable any of this, we need, heat pumps, as we just heard, rely on electricity to move heat. We need a low carbon grid because that electricity has emissions in it, especially as we use more natural gas. The forecasts show in the short term we're actually increasing emissions intensity. That's the chart on the bottom. Their long-term plan is to add generation while decreasing intensity, meaning renewables. Of course, there's a plan to expand nuclear, et cetera. But the point is, the crux of the plan, the crux of achieving our goal rests on a low carbon grid. One of the challenges there is rapid demand growth, at least forecasted in the next 20 to 30 years. So this is from an IESO forecast. I think it's a couple years old now, but fundamentally, given the drive to electrify all the end uses, whether it's heat pumps, electric vehicles, et cetera, demand is set to increase substantially. Forecasts are imperfect, but there's reason to believe that demand will grow significantly to the point where we actually potentially become a winter peaking jurisdiction when in the past we've largely been summer peaking. And again, because we're still somewhat heating dominant, as we bring in more heat pumps, that shifts our peak to the winter months, which is relative. Well, it hasn't always been summer peaking in Ontario, but it has been for a long time. And so this is a challenge that we're going to have to manage as we think about growing the grid. Also, some important context. So regional electricity planning is underway. You might have heard of the Integrated Regional Resource Plan. This is important for many reasons. But one of the key considerations is, Don, you talked about gas plants. The Portlands Energy Center is Toronto's gas plant. This is, of course, in the Portlands. It's a natural gas-fired combined cycle power plant. The contract for that is set to expire in less than 10 years. But this is one of the 3 key points of supply to Toronto. We have 2 major transformer stations, and then we have the energy center. So the question is, what do we do in 9, 10 years time when this contract expires? Because there's a risk it may not be renewed. We'll see. That's out of our control, but fundamentally, we need a plan because that's 600 megawatts of firm power. It's going to take a number of things to deal with, but one of the options that the province is currently considering is new transmission. That's not going to be easy, and it's not going to be fast. 9 years, 10 years, be rapid for a new transmission of this scale. The reality is this is one way or another, we're going to be facing either through growth or through lack of decrease in supply of generation. We're going to need to think about conservation, renewables, all of these kinds of things. But what I want to talk about is district energy. And even though that's thermal energy, it plays a role. And I'll get into it in a little bit, but just to give you a sneak preview, district energy can go a long way to reducing the demand on the electricity grid by basically reducing the amount of electricity you need for all these heat pumps. Because thermal energy networks, district energy can unlock large-scale thermal energy solutions that are much more efficient than sort of air source heat pumps, for example. So that's going to be, I think, a key role in the future for district energy. So about 10 years ago, we did a scan of the opportunity. No surprises, district energy coincides with growth nodes. And so whether these are large new developments, reconfigurations of post-industrial sites, malls, all the regional malls in Toronto are being developed. That's where there's an opportunity for new nodes. We're also fortunate to have several large existing systems that can both be expanded and fuel switched over time. And then we have existing and planned regulation that will require consideration of district energy because as you think about carbon targets, whether it's for new or existing buildings, district energy becomes part of the conversation there. And I'll explain some of these in the next slides. So important context, we don't regulate in Ontario, the Ontario Energy Board does not regulate thermal energy supply. And the city currently, as far as we know, does not have the authority to mandate connection on private property. So our approach is we regulate what we can, which as I'll show is primarily buildings, land use. We lead by example where we own assets, whether it's infrastructure, buildings, land, and then we have ways to encourage and incentivize uptake. So in terms of the regulatory side, you've probably all heard of the Toronto Green Standard. Well, essentially what that does is that puts us on a path to achieve net zero emissions development by 2030. And so the chart on the right basically shows what that looks like. We're currently studying the opportunity to accelerate it, potentially to get there by 2028, but fundamentally by 2030, all new buildings will have to not use any fossil fuels to get approved. And so that's a key part of our climate plan and our ability to reduce emissions from development. But of course, development's only part of the story. Right now, my colleagues are working on standards for existing buildings. The acronym there's BEPS, it's Building Emissions Performance Standards. Essentially, that might look like a bylaw that actually sets certain carbon targets for existing buildings, but it'll be paired with all kinds of programs to, of course, support owners as they try to implement some of the solutions that they'll need to meet the requirements. But it's planned, meaning the staff report on this is coming later this year in Q3. And so stay tuned for that because that will have a huge impact on that 56% of emissions that we need to address, which again are all from existing buildings. And so it's a really important policy and bylaw that's in development now. When that comes into effect, we better have solutions like thermal networks to help help developers or owners meet those requirements. Backwards. So one of the ways we enable access to thermal energy sources is we can provide information. And so the map you see, there's a map of the city of Toronto and all the trunk sewer network, the large trunk sewers with the models and in some cases measured heat that's available in those trunks. So you can recover heat from sewers and use that to actually displace natural gas. It's perfect temperature. It requires a little bit of a lift from a heat pump, but because sewage is typically 18 to 20 degrees Celsius, a lot less lift than you would need if it was an air source heat pump or even ground source. And so wastewater, which is just readily flowing and otherwise unused, provides a lot of heat that can be captured and and used to displace gas in buildings. And so I'll show some examples of projects. But I mean, fundamentally, geo-exchange, shallow lake-based heating and cooling, deep lake, even deep geothermal, these are all areas where the city is actively trying to enable the private sector, who we partner with, to deliver projects to help decarbonize buildings. So this is how we lead by example. So I'll start on the far right, because we were just talking about wastewater. That project is currently under construction at Toronto Western Hospital. It's our first wastewater energy project. The project developer is Noventa Energy. The client, of course, is University Health Network at Toronto Western Hospital. It doesn't look like that picture anymore. I need to go get a more recent one, but basically in the summer will actually be the ribbon cutting will be taking place. It's already providing heating and cooling. It's just being commissioned, working out all the bugs before it's sort of before the ribbon is officially cut. But basically, the Mid-Toronto Interceptor flowing underneath Dundas Street is providing 90%. It's reducing emissions to the hospital by 90%. 90% less gas use at Toronto Western Hospital because of sewer heat. And so that's an amazing story. It's over 8,000 tons of CO2 per year that's being entirely removed, all because the city provided access to both the sewer and the right of way, so Noventa could install their wet well and run pipes to serve the hospital. And so we have other projects now underway to try and scale that up. In the middle, we decarbonized one of our own buildings by putting a small heat exchanger in one of the slips along the waterfront. Basically, it's the waterfront neighborhood center, and it's entirely off of natural gas for heating, by instead using the temperature of the lake all year round to provide heating and cooling instead. So that image there is the heat exchanger actually being located in the water. This is basically at close to the foot of Bathurst Street. On the far left, although it's a rendering, that building, the Etobicoke Civic Center, is currently under construction. A city civic center surrounded by several blocks of housing. Underneath the civic center is the first bore field. The first geothermal bore field has been drilled. Once building is complete, the energy center in there will take that energy from the earth and feed that through a district energy system to all the housing blocks surrounding it. So the city is providing space for an energy center operated by Enwave to provide heating and cooling to all of the housing blocks. So this will be 3 million square feet of buildings that's not using any natural gas for heating and cooling, which is quite a feat. I'm going to go through some of the existing projects that we have quickly, just to show you some other flavors of what district energy looks like. So this is Exhibition Place. On the left there, you see Hotel X, which is the hotel that was constructed there around 10 years ago, I guess, a little bit less. We're serving that with a district energy system from the Enercare Center across the street. That's the Enercare Center there. Here where my mouse is, you can see a small patch where pipes were installed to cross the street. This is a photo I took from the rooftop of the hotel. The only indication that it's connected to district energy is this patch here and some equipment on the roof, but very little, far less than what would have been there had it not been connected. These are the pipes running through the parking garage of the Enercare Center. What's really interesting about this project, when we built this several years ago, it's on natural gas, it's providing hot water, not a big decarbonization story, still a good story in terms of providing resilient energy to the hotel. But fundamentally, we are now planning a large-scale fuel switch to wastewater energy that's being enabled by having this thermal network. That's the only way you can do this kind of large-scale decarbonization, is having that infrastructure in place. This is deep lake water cooling, 20 years apart, when the first pipe and then the fourth intake pipe were installed in the lake. This is, one of Toronto's biggest success stories, taking cold lake water and using that to cool many downtown buildings. What's really interesting about this project, so this is a schematic of it. What's really interesting now is, although it's primarily a heating or cooling system, meaning lake water at 4 degrees Celsius is then circulated through buildings to provide cooling. When the water, once it goes through the buildings, it's actually warmed up enough to the point where Enwave is now using that, and they're putting heat pumps on that return to actually provide heating to some of those same customers, because you have to lift it from a lower temperature, 12, 13 degrees, up to space heating temperature. So they can use the same system to provide also low carbon heat. Again, the value of a thermal network is that it enables you to do that at scale. So they're able to decarbonize the Royal York Hotel, a building that's probably 100 years old, using this type of technology. So heat pumps are an amazing tool The thermal network gives you the flexibility to use them in ways that are perhaps more efficient than using them at the individual building scale. This is Regent Park. On the left there, that's the only steam you'll see coming from Regent Park, left sort of in the middle at the top of the image, because all of the energy is contained, all the equipment is contained in one building. In fact, in the parking garage below one building, because Regent Park has a campus-wide thermal network supplied from a central plant. The steam, of course, means combustion. So there are gas boilers right now, but we're currently working with Toronto Community Housing to actually do a large-scale fuel switch there as well. It's too early to say with any certainty, but I'll say the same sewer that we use to decarbonize Toronto Western Hospital flows right on Gerrard Street in front of Regent Park. So there's an opportunity there perhaps to use wastewater energy again to decarbonize several million more square feet of existing buildings and several million more to come. That's the power of a thermal network. You could not do wastewater at the scale of one building. And so instead of drilling a few thousand boreholes for geothermal, you do one wet well, and that's your fuel switch, one shot, done. This is just what Regent Park currently looks like and a rendering of what it may become. The point is, I think the takeaway here is that you can do a fuel switch when you have the thermal network. It definitely helps to have ongoing growth to connect new buildings. And it's really important we decarbonize new buildings when we have the chance, because existing buildings are more challenging to do. And so, again, the thermal network enables all of that. I spoke a little bit about the Etobicoke Civic Center precinct already, but here's what some of the images look like. Basically, all of those housing blocks, which is on land that the city owns, we're requiring the developers to connect to the district energy system that we developed in partnership with Enwave, which is housed at the Etobicoke Civic Center, a building that will be a city facility. So on the left there, you see the geothermal rigs. This is just drilling the first bore field. There will be, I think, 5 drilled, and they'll be networked together, and that's how we'll get all the heat and cooling necessary to decarbonize the whole thing. This is a rendering on the right of Block 1, which is under construction. So the housing is being built, which is a great news story because we desperately need affordable housing, but this will be affordable housing that doesn't use any fossil fuels. I mentioned Enwave a few times. For those of you that haven't heard of them, they're essentially the legacy district energy system owner in Toronto. The map there shows their coverage in the downtown core, but of course we're working with them on nodes outside of it. They are actively expanding and decarbonizing their system, which again, having that network is key because we can decarbonize a lot of buildings at scale, as opposed to doing one building at a time if they were straight up retrofits. The image on the left there is when it was under construction, they were building a large thermal storage tank underneath the well development at Front and Spadina. They store basically hot and cold water there. They use that to provide heating and cooling to buildings seasonally. It's an example of the kind of solution. I mean, that's a huge tank. It's the kind of scale that you can achieve when you have a large district energy system. Just to give you a sense of what the infrastructure looks like. On the right is the Portlands, or Villiers Island, which is now called Okwim-Minising. That's the indigenous name. That is going to be our next system that we work on with Enwave, where millions of square feet of new development, potentially an extension of their existing system, potentially a new node, but one where we're trying to get to zero fossil fuel use at scale. And plans are actively being developed now to do just that. One extra slide on the Portlands because it's such an important area. I talked about the Portlands Energy Center already. That's part of the context, as is the fact that there's already large-scale electrical and thermal infrastructure in proximity. And it's a working port, and it has industrial land. This is an area where we think energy planning is going to come to a head, and it will show what we can do with municipalities working together with their utilities and the IESO, the electricity system operator, to plan for energy, not just electricity. Meaning, we know we're going to need electricity, but there's an efficient way to do it, as I alluded to earlier, and that's by letting thermal energy do what it does best, which is provide heating and cooling, and use the electricity for those things that need direct electrification. This is a way where maybe it means we need, if it's a transmission solution, smaller wires. Maybe it means we can defer when those wires are needed. there's huge savings in terms of cost by thinking about what thermal solutions can provide instead of just assuming that air source heat pumps will take up most of the slack. And so there's direct benefit to taxpayers and ratepayers by thinking about the value of thermal energy. And that's something that we're trying to do in the Portlands with the groups that I mentioned. Just quickly on policy. So I'll say there's a lot of ways to incentivize, require, encourage district energy. I'd say after we share these slides, when you look at it, we're probably light to moderate on district energy in Ontario, and there's reasons for that. We can talk about it in the Q&A. The point is there are other jurisdictions where there are strong mandates for district energy, including in Canada, BC, for example. We don't have that here in Ontario, but there are still things we can do to help tip the scale in favor of district energy. Fundamentally, our focus is on decarbonization, but there's an important role for district energy that sometimes requires additional policy support, and so that's something we're working on as well. This is just an example of what ownership can look like in different jurisdictions. So the interesting thing about district energy, it can sway from entirely public to entirely private. And you can see examples close to home here, and as well as abroad. All of these have pros and cons. The reason I bring this up is because there may come a time when Toronto has to think about what its role might be in district energy. And I'll show on the next slide that we have had ownership stakes before. We're not in that business currently, but in order perhaps possibly to scale up district energy activity, we may need to, again, be in the ownership position. So this is just, again, so when you look at this later, you can get a sense of some of the different models that exist. This is where the city has actually played a role in district energy projects, in fact, owned some of them. So I mentioned Exhibition Place. Of course, that's a city board of governors. We own that. We at a time owned Enwave, and we sold them. They are now owned by pension funds. But fundamentally, we were for a long time in the district energy business. We, through Toronto Community Housing, own Regent Park as well. But they operated entirely, as a corporation unto itself. The Etobicoke Civic Center, our role there was to help with the initial development, but that's going to be Enwave owned and operated. But so this gives you a sense of some of the different models that exist here just in Toronto. District energy is not unique to Toronto by any means. There's many projects under development across the GTHA. These are just a few here. Maybe most notably is Lakeview in Mississauga, just west of Toronto, where there's a major wastewater energy project, but instead of tapping into the trunks like we're doing in Toronto, they're tapping into a treatment plant effluent, huge source of heat, which is great to see. So quickly on the business model, which complements sort of the policy and ownership discussion, and this is important. As I mentioned at the beginning, district energy is not the traditional utility. In Ontario, because it's unregulated, these are private companies that are deploying their solutions. So they have to make their money on shorter terms than a utility would. So typically they have 20 to 30-year agreements where they'll put up most of the upfront capital and they will recoup their investment through fees that the customers will pay. Basically, that's how they get a return on their investment for them and their investors. The model basically shifts upfront costs to ongoing operating costs, which that's why utility models are so attractive, because the longer time frame you have to amortize that equipment, basically the more you can justify in terms of the upfront investment, which renewables require. And that's part of the challenge for district energy being unregulated, is that because it's profit driven, there can be an upfront cost premium to doing this now, especially without the carbon price. Or you need the ability to extend the agreements for even longer periods of time, which 30 years can work for some projects, but to give you, gas utilities can have 40 or 60 years, right? And so that really helps. And so as we think about small scale systems, we need to think about what the right model is. The reason I bring up small scale, and I'll get to it in a second, is because there may be an opportunity in neighborhoods to have their own district energy systems, but they're going to look a lot different than the kinds that I just showed you. These images here basically show that for the same reason we think of large scale, there is value to think about, let's say, small scale geothermal district energy systems in neighborhoods because they can help reduce peak demand, where I think those issues are going to be most prevalent. We will see electrification challenges, I think, to start on small streets where a bunch of people buy EVs or install heat pumps. And so I think there will be a role for small scale systems at some point, but we need the right business model to unlock that. So, and I'm not saying necessarily it has to be regulated in some way, I think is ultimately what I'm saying, in order to scale it up, especially with small systems. So we need a rate base, we need the ability to amortize it longer, and we need ways to, connect at scale. It can't just be a company or going to each individual homeowner. It's very cumbersome. And so, I wanted to basically just give you a sense of why there's some of the challenges doing small scale district energy. It's something we can talk about. It will, I think, require a change in how we think about providing thermal energy and the role it's going to play. That conversation has come up several times before the Ontario Energy Board, our energy regulator, but thus far they have declined to regulate it. But I think before long we will have to have a serious discussion about the role that thermal energy plays and what municipalities and utilities will do in that space. So that's basically it. I think the last slide here is just my contact information and some resources. So again, once these slides are shared, there's a bunch of links in there. Feel free to click through and you can do some additional reading. And happy to answer any questions if we're going to that. Now, Michael, I'll hand it back to you.
Thanks so much, David. By the way, David's bio doesn't mention that he's very approachable, and it's very good as seniors to have contact with people who perhaps are a little younger than us in this very rapidly developing field. So we can take a break now, or we could, if there are questions, we can maybe answer a few of those. Dawn, maybe we will take some questions, and if we have them and then.
Well, we none of our guests have typed questions in yet, but perhaps this is a good opportunity if you do have questions to type them in. I've typed in a couple, but this isn't for me. This is for everyone else. So please take a moment and think about that fleeting question and grab it, and please share it for either Peter or David at this point. In the meantime, maybe I can sort of get things going a little bit. So actually, question for Peter, coming back to our first presentation. And this one is in the Q&A. Peter, for retrofitting a single family home, what's the impact of the home's existing energy system? Forced air, baseboard, radiator. What are the possibilities of retrofitting? What kind of costs do you think we're looking at?
The least expensive would be a forced air system. You already have the ductwork. And for an air source, you may be in the $5,000 to $10,000 range. There are incentives available from various levels of government, and the heat pump dealers will be well aware of those incentives and kind of include them in your final costs. So it'd be maybe less. Would be the least expensive way to go. If you do not have ductwork, then you will have maybe a $3,000 to $5,000 installation charge for putting ductwork in, and that might include holes in the floor, and it could include ripping up walls to put ductwork in. I don't think you want your duct mounted directly on a wall, so it should go in between the studs. So there'd be a little bit of rip, tear, install, and patchwork. And it could easily be these days more than $5,000. If you have existing electric, or radiant heater. So you have a boiler system with radiators. I would use those. I wouldn't get rid of them. I'd keep them as the backup, because you will need to have your house sized up for a heat pump system, and you may have a 1 ton plus a 2 ton system, for example, and that would look after you year round, except for the 10 or 12 coldest days in the winter. And that's when your supplementary baseboard or radiant heat could come into play. Or you may have your fossil fuel backup may have to come into service for to give you a little extra heat on those 10 or 12 coldest days. So they for your baseboard and radiant heat system, you can dial those down while your heat pump system does the job. And then if you need a little extra, you see the choice between turning on your supplementary heating or putting on a sweater or two. Then the other thing to consider is in the ductwork, if you want air conditioning, the air that moves through the house and therefore through the ductwork to be cooled off by the heat pump system would be including moisture in the air, humidity. And one of the things that makes you more comfortable with air conditioning is it reduces the humidity, and you feel a lot more comfortable with that. But the humidity would condense on that A-frame heat exchanger in the ductwork, and it's going to drip, and it will drip into a collector pan, and that pan will drain down into a floor drain in the basement and go away. If you don't have that drainage system, you're going to find yourself with a 5-gallon pail of water per day to deal with in the basement. So you have to bear that in mind, and that might be another $200-300 to get the copper tubing from where your heat exchanger is, your A-frame in the ductwork, down to a floor drain.
Thank you.
Don, if people are interested, so I have a 1950 bungalow in East York. I got my heat pump in October. It's a cold climate air source heat pump made by Mitsubishi, so definitely sprung for the premium product. Just to give you a sense, that was $20,000. The other option for me was another cold climate model, basically as good performance as the Mitsubishi, without, let's say, the long track record of operation of that company. And the price there was about $13,000. I have a forced air system. So as Peter talked about, standard installation, replace your furnace and AC, and you know, there you go, barely no modifications to the ductwork. So that was easy. It's important, I did not have to upsize my electrical panel. I have a 100 amp service. I checked with Toronto Hydro before my installation, and I think about 25 amps was my peak. Again, it was on all natural gas. I checked afterwards. I peaked at less than 50. Now I don't have an electric vehicle, but I have now an induction cooktop. I have a heat pump, and I have a hot water tank, electric hot water tank. The point is, and that's despite the cold winter we had. We had quite some very cold days this winter. So if any of you are thinking heat pump, if you go hybrid, you definitely don't even have to consider it. But I would say if you have a 100 amp panel and you don't have an electric vehicle, you may not need to upsize your panel, and that can save you several $1,000s. Now, if you get an electric vehicle and you want level 2 charging, you know, you could maybe get away with it with some smart controls, and so you want the right energy advisor to walk you through that. But it may be safer to upgrade if you add an EV or especially two, unless you want to do slow charging. So there's some consideration there, but it's not cheap. Hybrids are definitely more cost effective. Now, the only reason I went cold climate is because both my furnace and my air conditioner were end of life. And the other reason is because I wanted to eventually, in fact, I just closed my Enbridge accounts because that alone saves you almost $400 per year, and that can help with bringing the cost down. So
It's
some
about
choices.
$32 a month minimum from Enbridge.
Yeah, just to have a meter basically that's
Yeah.
that's open. So there, if you're in the position where you have to replace both pieces of equipment, it may not make sense to go with a hybrid. But if you're in most people's position, which is an older furnace or an older AC, let's say, you keep your furnace for those cold days, and then the heat pump does most of the work and still gets you significant emissions reductions and cost savings. And then you also get a much cheaper heat pump up front. So you can, for a while there, with some incentives, you could basically pay for the heat pump just with incentives. Those units that are not cold climate are easily below $10,000.
Is it true that, and if you do that, if you get a combination rather than no gas, that Enbridge sends you a gift every Christmas?
No comment.
I made that up, but
I know. They definitely don't want to lose you as customers, but
no, and they don't care if you use gas, just stay connected. That's all they want.
there's definitely a role for hybrids to be honest, for a period of time. I think if your AC is end of life, you should definitely consider a heat pump. Is what I try to say to people.
May I toss in one additional thing, even though I'm supposed to be, this is just from our experience. We live in a house that's about 100 years old, and the heat works just fine. But the problem we discovered when we installed a heat pump was the air conditioning. That in an older home that was never designed for air conditioning, there's nowhere for the hot air on the second floor to go. There's no return. Consequently, the air conditioning is completely ineffective on the second floor. And there are a couple of ways of dealing with it. We ended up with getting splits, just a couple of small um, wall-mounted units, and they work really well. But another thing you could do that's simpler and maybe less expensive is cut a hole in the floor, and that will allow the circulation of air. At any rate, um, should we should we move along? I mean, we could kind of
I think we'll take
chat.
a little. We'll take a short break before Gail Fairley's presentation. So, people, if you have questions, please put them in the Q&A. It's perfect time, and we'll take a break till 3:05.
Thank you.
See you then. Great. Let's get started again. Our next speaker, Gail Fairley, will introduce us to the concept of embodied or upfront carbon. Our question and answer session, a longer one, will follow Gail's presentation. And reminder to please put your questions in the Q&A. Gail Fairley is a retired social worker. She has a special interest in building a post-growth future, which entails using less stuff individually and sharing a socially abundant community life. In other words, individual sufficiency and social abundance. She applies this outlook to providing sufficient housing for all. Over to you, Gail. Gail, you're muted.
Sorry about that. Sorry about that. It keeps
Would you like me to run your slides?
you can just get me back to the first slide, which it doesn't seem to want to go to.
But I'll be running your slides from then on. Is that all right?
Oh, okay.
Okay. Okay, but you'll have to stop screen sharing.
Okay.
Okay?
Yep.
Okay, thank you.
Thanks. Thanks, Helen.
Okay. Oops. I'm making a mistake too. Sorry about this. Okay, playing from the start.
Okay, thanks. Okay, so this series is about decarbonizing the built environment, and I want to start with a quote from Samuel Alexander on his vision of a sustainable future. It's a way of life based on modest material and energy needs, but nevertheless rich in other dimensions, a life of frugal abundance. It's about creating an economy based on sufficiency, knowing how much is enough to live well, and discovering that enough is plenty. Next slide. So globally, buildings are responsible for 39% of carbon emissions. This diagram illustrates more precisely where the emissions come from. The green section is operational emissions. That's the energy needed to heat, cool, light, and power the building mechanics. It's 28% of all building emissions. The remaining 11 are upfront or embodied carbon emissions. These are the emissions that are released into the atmosphere during the production of materials and the construction phases before the building or infrastructure begins to be used. This includes raw material extraction, mining or logging, refining, transport to manufacturer, manufacturing, transport to the construction site, and the construction itself. Upfront emissions also include maintenance and repair, while the building is in use, and at the end of life, deconstruction, demolition, and disposal. Next slide. The Institution of Structural Engineers have produced a sustainability resource map that prioritizes better use of existing buildings and building new structures that minimize material use. They start with a hierarchy of net zero design. It's all about using less stuff. The top tier is to build nothing. Always ask the question, do we need to build at all? Is construction the best answer to this problem? It appears that in Toronto, this question is not asked. There are multiple high-rises going up, even though condo sales have plummeted, and many condos are left empty. The second tier is about building less. This begins with asking, can a building be repurposed, reused, or refurbished rather than demolished? When building or renovating, always maximize the utilization of space. Can a building accommodate more units for work or living? Does every housing unit have to have multiple bathrooms? The third tier is about building clever. Most of the embodied carbon emissions in buildings are in the building structure. Think towers, think steel, think concrete. The concrete and steel industries combined make up over 15% of all global emissions. So don't overbuild. Design the structure with as little steel and concrete as possible. The fourth tier is to build efficiently by using carbon-efficient materials and space-efficient designs. The bottom tier is about minimizing waste by using and recycling instead of sending waste to landfill, and promoting prefabricated components and buildings. Next slide. The greenest building is the one that is already built. In Toronto, 60% of demolition permits are for single-family homes. Currently, Toronto has 2,700 active demolition permits for single-family homes. Modest and older homes are demolished and typically replaced by ever larger single-family residences, with only a few multi-unit buildings thrown in. This pattern of redevelopment turns once affordable neighborhoods into more expensive enclaves. In some areas of Toronto where demolition of single-family homes is common, it has resulted in a decreased population, while at the same time residents are crammed into condos in high-rise neighborhoods with little access to green space. Demolition also contributes to mounting construction, renovation, and demolition waste that ends up in landfill sites. This volume of dump material also represents an estimated $4 to $6 billion of valuable material resources that have the potential for recovery and reuse. Sending potentially reusable material to landfill drives an increased demand for virgin materials and propels even further upfront carbon emissions. Slide 5, please. Okay, these houses are in my neighborhood. The one on the right has 2 apartments added to the original building. The other houses are built on lots where single-family homes were torn down and replaced with mega homes that were selling for close to $5 million. And my neighborhood is not a place where you would think there'd be $5 million houses. Next, please. Okay, this is a small apartment slide. Okay, these homes are examples of sufficiency and efficiency in housing. The one on the left is a photo of 5 stories of apartment buildings on top of shops, and it's built in Vienna. The other house is a modular design for a 6-plex with a gross floor size of almost 5,000 square feet. It has units ranging from 1 to 4 bedrooms. It provides sufficient space and is big enough to live well. Next slide. And this is a small apartment building with a single staircase. It's another way to maximize space, and it's good for your health to climb stairs several times a day. In buildings like this, the first floors could be for people who are older or with mobility issues. In Europe, single staircase apartments are common. So are 5 to 6 story apartments with no elevator. Both designs add space and allow denser housing on smaller lots, which could help bolster missing middle multiplexes. While common in both Europe and Old Montreal, building them has been banned in Canada for decades. Seattle has allowed single stairway buildings up to 6 stories since the 1970s, with a limit of 4 apartments per floor. And BC is in the process of allowing them because this kind of housing can accommodate larger family-friendly units. Single staircase building designs have adaptation benefits as well. They are more livable during extreme heat because their layouts allow for cross breezes in units, something now reserved for those living in single-family homes or townhouses. Next slide. So we're going to look at transitioning to low carbon building materials. Next. We'll start with steel. Steel manufacturing produces more CO2 than any other heavy industry. Global steel production doubled between 2000 and 2020, and it's growing. The world has a voracious appetite for steel. The steel industry is responsible for 7% of greenhouse gas emissions and 11% of carbon dioxide emissions globally. This is more than the total emissions from all the world's cars and vans. 75% of steel is still made in coal-fired blast furnaces. Producing steel in blast furnaces is a carbon-intensive process that starts with mining iron ore, limestone, and coal, and then heating them to 1,650 degrees Celsius in a blast furnace. But the industry is beginning to transition to greener steel. But retrofitting and building new is expensive, and the transition needs to scale up rapidly to hit net zero targets. True green steel is manufactured without the use of fossil fuels. There are several ways to make greener steel. The most common is the electric arc furnace, or EAF. These use recycled steel, which is melted using electricity. Steel can be recycled and melted repeatedly without losing any of its strength or integrity. But most electric arc furnaces are powered with gas, which makes the steel less green, but greener than if you make it in a blast furnace. Another way is to use induction furnaces. They use electromagnetic fields to heat and melt scrap metal, leading to faster and more energy efficient steel production. If scrap steel isn't used, impurities like slag, oxides, and other non-metal components are removed from the molten mix. Induction furnaces are used in India instead of electric arc furnaces. Another way is to use green hydrogen as fuel. Currently, green hydrogen can't be produced at scale. It's expensive and starts with iron ore that has to be mined. Next. On the hopeful side, 50% of the world's new steelmaking capacity will use electric arc furnaces. Algoma Steel in Sault Ste. Marie and Dofasco in Hamilton are transitioning to electric arc furnaces with expected reductions of carbon emissions of approximately 60 to 70%. Both will be powered with gas, with a plan to move to nuclear or green hydrogen in the future. There's no discussion at all in Ontario about using wind. Hot off the press is promising news from Europe. An Oxford University study concluded that in the UK, they already have enough steel to recycle in electric arc furnaces to meet its needs now and in the future. Over 50% of the scrap steel comes from the manufacturing process. Reclaiming end-of-life steel is an untapped resource and will be one of the industry's most important raw materials. And in Belgium, at the ArcelorMittal electric arc furnace, it will produce steel using 100% steel scrap powered by 100% wind energy. Next slide. I think you skipped one. Oh, sorry. Yes, thank you. Now we'll look at concrete. Cement makes up 10 to 15% of a typical concrete mix, but because it's manufactured using fossil fuel fired kilns, it accounts for up to 80% of concrete's emissions. Reducing emissions from cement is crucial. And how can we do this? Well, we can start by asking, do we need to build this? We can use less and recycle because concrete is totally recyclable. Most municipalities have specifications requiring primary aggregate only as part of its tenders, and these restrictions should be lifted. We can also use greener concrete. Lafarge Canada is transitioning its plants to produce only lower carbon concrete mixes. One product uses less limestone and other materials that must be heated to high temperatures, thus reducing emissions by 5 to 10% per ton. But that's not a lot if you're considering all the concrete that's going into the building of high rises. They are also producing a concrete building block, it's called carbicrete, that is carbon negative. Carbicrete substitutes steel slag, a waste product from steelmaking, for cement. The blocks are stronger and they're already competitive on a price per unit. They're ideal for low and mid-rise building, but not suitable for towers. Next slide. Towers are carbon bombs. They require a lot of steel and concrete for stability and to resist high wind speeds. The higher the building, the more concrete and the more steel required. Every floor is a reinforced concrete slab. The taller the building, the deeper the concrete foundations. The more underground parking, the more concrete. In 30 and 60% of mid-rise and tall buildings, upfront emissions are below ground. Tall buildings also require more energy to operate because large glass areas are difficult to heat and cool. Mechanical services that raise water, coolant, and people to great heights are energy intensive. Toronto has the third highest number of skyscrapers in North America. There are more than 100 high-rise buildings currently under construction and another 30 that are proposed or approved. A UK study found that building 20 stories or higher use 2.5 times more electricity per square foot of floor space than buildings with 6 stories or fewer. And tall buildings are not as space efficient as you would think. The amount of floor space taken up by lifts, stairways, and mechanical services make them one of the most inefficient building types. Toronto has a glut of condos on the market. Condo sales have plummeted and developers still continue to build more. And the housing market has become less egalitarian for space and livability. Ontario condominiums are 35% smaller on average than they were 25 years ago, while the average detached home is 25% larger. The average condo size built since 2017 is 659 square feet. Next slide. Now we'll look at mass timber. It's engineered out of laminated lumber, veneer, and wood strands, and where available, recycled wood. It's lighter than concrete or steel, but strong enough for load-bearing beams and columns. Building with wood can have a much lower carbon footprint than building with concrete or steel, but not always. It depends on how the wood is harvested, the way trees are replanted, and the ongoing health of the forest. Although 94% of Ontario's managed forests are sustainably certified, the sustainability certification programs have come under scrutiny for making concessions that have allowed a lot of logging of older forests. Next slide. Canada's managed forests is one of the largest living reservoirs of carbon on the planet. Canada's forests have moved from a carbon sink to a carbon emitter over the past few decades due to logging and replanting practices, wildfires, and increased insect damage due to climate change. This chart shows the change in CO2 stored in Canada's managed forests from 1990 to 2020. The blue line at the very bottom is cumulative carbon gain. The blue line stops growing by 2000. And the red line is cumulative loss, which is going up at an amazing rate. By 2020, the accumulated loss was 3,300 metric tons of CO2. The fact is, there are not enough trees to harvest the quantities needed for housing. We need policies and regulations that promote good forest management practices, building efficiently, demolishing as little possible, renovation only when necessary, recycling wood from renovations and demolitions, and using small pieces of lumber for floors and beams instead of large timber pieces, so that we can leave the large trees in the forest. Next slide. Building modular homes increases efficiency and sustainability. Constructing building parts in a controlled factory setting allows precision engineering that reduces waste during the building process. Leftover wood and other materials are set aside and used in other projects. It also allows the use of sustainable materials such as mass timber, low carbon cement, and low carbon insulation. You can build to high standards of insulation and air tightness, use energy efficient windows and doors. A bonus is that construction time is reduced, transportation of materials is reduced, there's less disruption to local environments, and fewer emissions. Locally sourced materials and small modular factories create local jobs. Modular homes typically have no basements and can sit on concrete slabs or wooden piers. Used above grade, wood building materials undergo natural drying processes that help make them remain viable for decades. And it's relatively easy to replace wooden piers because they're above grade. A 30 to 60 year replacement cycle makes it feasible to maintain a building over a very, very long period. This is the ideal way to adapt to increased flooding because there is no basement. Next slide. So the federal government has issued a new housing catalog. It's a collection of nearly 50 free standardized designs for multiplexes, townhouses, and backyard suites. Architects from every province and territory designed homes that meet local needs, conditions, and building codes. The housing design catalog will help builders streamline the process from concept to the end of construction. It bypasses the need for an architect, ensures compliance with building codes, and helps estimate costs. It speeds up housing delivery and all but eliminates disruption in neighborhoods. Last week, a house in East End, Toronto was erected in 72 hours. This design has 6 apartments across 3 stories, 5 two-bedroom units and 1 single unit. Next slide. Here are 2 more examples of modular apartment buildings from the catalog. They're designed by architect Jana Levitt, who prioritized wood-framed buildings with no basements and emphasized energy efficiency and accessibility and aging in place. Next slide. And this is a prefab rental building that's going to be built at 1925 Victoria Park. Next slide. The greenest building is the one that's already built. Over 50% of Canadian homes will require retrofitting in the future to reduce our carbon emissions. Here are some ways for buildings can be retrofitted or improved for energy efficiency. And we're not looking here at heat pumps. You can start by filling cracks with caulking, replacing inefficient appliances with high energy models, adding shading to windows, adding insulation to walls and roofs with low carbon insulation, like dense pack cellulose. It's also the cheapest product in terms of insulation. Reducing overall oversized windows, replacing window glass with double glaze or low E glass, installing green roofs with native vegetation, installing solar photovoltaic systems to power the building's lighting and electricity needs, and adding building integrated photovoltaic panels to the building facade. Next slide. Construction, renovation, and demolition waste is not regulated in Ontario. And the only regulation is in Toronto, and I think this is probably true all over Ontario, is that CRD waste is prohibited from entering the residential municipal waste streams. So it ends up in landfill. Contractors and homeowners deal with renovation waste privately. In Canada, 61% of all CRD waste is residential, and almost all of that is from home renovations. Home renovations produce a whole lot of waste. Next slide. Next, please. Yeah. Canada produces about 4 million tons of construction, renovation, and demolition waste every year. CRD waste includes concrete, wood, metals, glass, and plastic. Only about 20% of that waste is salvaged, reused, or recycled. Studies show it is possible to salvage as much as 95% of CRD waste through reuse and recycling activities. Salvaging and diverting waste from landfill creates jobs, reduces pressure on landfill sites that are nearing capacity. It reduces the risk of pollutants causing harm to humans and natural ecosystems, and it reduces the need for new virgin construction materials. Next, please. Less waste could be produced through design and regulation. New builds should be designed to deconstruct, not demolish. Modular housing should be prioritized. Building codes and green building certifications and policies should include dealing with CRD waste. Regulations that restrict demolitions and/or charge very high demolition permit rates would go a long way. And permit fees can have built-in rewards if waste is separated for reuse or recycling. And most importantly, the promotion we need promotion and incentives to stimulate the growth of local companies to harvest CRD waste, sort, refurbish, and sell reclaimed CRD waste to builders and renovators. Next, please. And we need to look at circular product design. It focuses on methods and designs that eliminate waste in a system. They include a building and product design that is durable, requires low maintenance, and has a long life expectancy. It's the opposite of planned obsolescence. It allows for disassembly and reuse of recycling of building materials. It uses local products and materials. It incorporates lean construction policies that limit overproduction, overstocking, waiting time, transportation, and extra processing. Consumers and other key stakeholders like construction and demolition workers need to play a significant role in developing the logistics to keep materials in the loop. Next, please. Okay, this is the last slide, and I'm going to end with some advice from the Architects Climate Action Network. The first is to measure and regulate embodied carbon in everything. And the second is to require every new build to have a whole life cycle carbon assessment completed at an early design stage. It should be submitted as part of the pre-application inquiries process and the full planning submission, and be part of the full planning submissions for all developments. Thank you.
Thank you so much, Gail. That was very thorough and a very welcome reminder about embodied carbon. And I'll turn this over to Don Booth, our Q&A coordinator, for any questions we have.
So feel free to type your question in, but there also at this point, there's no reason if you would like to just ask a question verbally, we could certainly do that. I just have one question so far, which is how can we actually recover material from a demolition? I mean, it's been demolished. Everything is all broken up. How do we recover that and use it again?
Well, I would have to look at it's done in a lot of places. Canada is the worst for recovering this waste, and so I could certainly get more information on it. But I think it comes down to when you are demolishing something, where you put the stuff that's coming down. So you start separating. But it's because it's worth so much money, then we need companies who are going to, based on the way it's been done elsewhere, come up with strategies for how you sort it and refurbish it and all that kind of stuff.
So, Don, if I can add, there's a couple, we're doing a deconstruction project right now. The city is leading one. It's a house. It's basically the end of a row of houses. It's on city property. The site's going to be cleared for new development. In fact, our first mass timber building. But right now we got to move this existing house, and so instead of demolition, we're deconstructing it. We've hired a firm called Ouroboros to do the work, and instead of taking a large piece of equipment to it, they basically take it apart much like it was put together. It's obviously very labor intensive. It's slower than traditional demolition, but the idea is it preserves materials that can either be reused on another project or for the same use or reused in a different way. So that's a house. So we're talking dimensional lumber, maybe brick. Things have to be denailed, cleaned, perhaps. So it's not cost effective right now. We are looking to change that through policy, like some other jurisdictions have done. But the principle of larger buildings is the same. The difference is some of the material in larger building has inherently more value, like steel, for example. Demolition companies can just wreck it and they will sell it as scrap. It doesn't have to be used for structural purposes, although it could be if it's regraded. The point is, as Gail talked about, it's really not done it's not a strategic sort of approach at this point. So in Toronto, our approach is to do some pilots, figure out how we can scale this up, and then with my colleagues in the circular economy group, perhaps work on a bylaw or a policy that starts to require or encourage, otherwise incentivize deconstruction as opposed to straight demolition. Because there's a lot of value in those materials.
Thanks, David. Mike, you have your hand up.
I was curious. I don't know why my mind is on the federal government. Have the city been involved, this is for David, in any district energy projects with the federal government, either directly on federally owned property or through CMHC, anything of that,
We did receive some funding from Natural Resources Canada for some of the district energy development work. So the studies that would have helped to determine essentially the business case for some of these projects. So I would say they've been involved in due diligence. Definitely, so at the Etobicoke Civic Center precinct, the CMHC is pretty much the only funding source for a lot of affordable rental. And so indirectly, they are involved. But I mean, their energy requirements that come with funding are less stringent than in Toronto. And so they're not really, I wouldn't say they're requiring it, not even close, really. The other thing, though, we've also got some funding from support from the Federation of Canadian Municipalities. So again, indirectly at the federal level. I say indirectly because they do get funding from the federal government, but they're an arm's length agency. So we haven't done any, I can't think if we've connected any federal buildings. Not that I can think of recently. Enwave may have some customers that are federal, perhaps, but I'm not 100% sure. We may have, again, indirectly, we're working with Waterfront Toronto, which is a tripartite agency on a large-scale district energy project in the Portlands. So a lot of indirect, I guess, involvement.
Marilyn, you had a question?
Yes, I submitted two, and I guess they're just not showing up. And
I submitted one as well.
maybe others have also had some. Anyway, I think mine is for David, probably. We have a heat pump. Our backup for colder days is gas. I'd like to get off that fossil fuel for the heating at least. I've learned that I could probably purchase a 15-watt auxiliary electric strip in for the air handler. But I don't know for sure if that's the best option for our home. So my question, and I think it's probably a good one for many others on this call too, who can we look to for the expertise to let us know that and how best to proceed, what the best options are?
Yeah, well, so I'll start answering, and then maybe I'll pass to Peter as the heat pump expert. But the city is providing what we're calling like concierge services for residents, basically to help guide them through, let's say, the process. So in your case, you've already purchased and installed a heat pump, but the idea is city staff are taking a role in advising as well, at least to the point of making sure that you have the right strategy in mind, and maybe advising on contractors, and because there's a recommended contractor network, things like that. If you'd like to get in touch, I can connect you with my colleagues who work on existing buildings, particularly, and they can advise in terms of options for you. I will say, actually, you know what? I'll let Peter. You go ahead if you want to add anything. Yeah.
I noted your email address, so is that what I use?
Yeah, absolutely. Yeah.
Thank you so much.
Yeah, you're welcome.
Yeah, a lot of manufacturers have an applications engineer.
A little quiet, Peter. It's might be far from the mic. Oh, there you go.
Yeah. Yeah, a lot of manufacturers have applications engineers, and they can get some information about your home, what you've got, square feet, and what your insulation levels are in the walls and the ceilings. They can determine what your heat loss would be, various temperatures, what your heat gains may be in the summer, and so on. And then if you're putting an electric element, and did you say 1500 watts?
A 5 to 15 watt was what was suggested as the backup.
Not good.
No.
That would be like excuse me, having a 5-watt light bulb in your duct system.
Okay, I didn't see any zeros.
No. So there are electric plenum heaters that would go in your ductwork, and they usually may be staged in 3,000 watt elements. And so if you have 5 of those, the thermostat would and the controls would energize or de-energize them depending on heat demand. But you'd have 3, 6, 9, 12, and then 15 kilowatts of heat available. And if you're doing that in conjunction with a heat pump that's installed, you may only need maybe 3 or 4 1500 watt elements.
Gotcha.
But that would be what may have been suggested to you is like the little light bulb that goes on in a little kid's pretend oven, and that wouldn't do.
A big thanks to the people who organized this, because I'm finding it very practical. Something that, homeowners can actually use. So very much appreciated. Thank you.
Thanks, Marilyn.
Uh,
Say, everyone, we're having a problem with the Q&A. So I'll ask our system operator, Helen, if she would please open the chat for everyone. And if you have questions, please just put them in the chat addressed to all, because it seems that the Q&A isn't working. Gail, you have a question? I'll keep a list.
Yeah, it's probably for David. I'm just wondering about I was speaking to someone from my counselor's office about a high rise that's going up in my neighborhood. It'll be the only one at a corner on Bathurst. And she was saying that, you can, when developers want to do something, the community and also the city can kind of try to persuade them to do things a bit differently and in a better way. But in the end, the province just pretty much rubber stamps what the developers want to do. So is there any way of getting around that?
So the only time the province sort of would get directly involved would be if there was like a ministerial zoning order that approved it, or if it's like a transit-oriented community or something like that. So the province through the Ontario Municipal Ontario Land Tribunal also
Yes,
is
yes.
the appeal body
That's what
that
I meant.
okay. Yeah, I mean, I can't recall there are restrictions on how you can intervene in a hearing. There are restrictions on third-party appeals. So you and your neighbors, let's say, would be a third party. I don't know exactly what they are. You'd have to look into basically. It used to be that you just pay a small fee and you can appeal. They have changed that in the interest of expediting things, but I don't know what the current rules are. So if it's reached a point where it's at the OLT, you would have to look into applying to be an appellant, basically, if you want to have formal status. Otherwise, your roots are more advocacy, I guess I would say. And of course, well, not of course, but you would probably want to look into hiring a lawyer, I guess, if you're going to the OLT to actually intervene. Yeah.
Lynn Blacksley.
Hi. My question actually goes back to earlier in the talk. I did put it in the Q&A, but I guess it was one of the ones that got lost. It's for David, but you did again just a few minutes ago, David, mention the potential project or the big project in the Portlands. And you specifically mentioned the Uklemin Menacing as being the site for the next potential project with N-Wave. And I'm wondering if there's any possibility of that extending slightly further east to other developments in the Portlands, like the McCleary district, or is it something about the structure of the previous Villiers Island that means it's more constrained to just that area?
Oh, no, it would extend, the vision is to see it extend to the entirety of the Portlands. And basically, as long as there's an opportunity, we will extend it where it makes economic sense. The only reason I mentioned Oakham and Minising is because that's where the development will start. Basically, that's the first phase, really, is the island. But in fact, the planning work for McCleary has already started, and part of that plan assumes expansion of the thermal network to serve that as well. It's just sort of development roughly is proceeding sort of from west to east in that direction, and so it would start on the island and then move eastward, ideally. Yeah.
Okay, thank you.
You're welcome.
Lynn Ovenden.
Yep, hi. It's just a question. I read about a story about this happening in the States somewhere. The idea of transforming a utility gas pipeline network into something useful for district heating, like becoming a thermal network, I guess. Is that happening anywhere in Canada, or is it being considered?
So from what I've seen, you can't just reuse the pipes the way they are, because they're too small really to transport the volume of water you would need to use it for, let's say, heating and cooling. it could mean that you're referring to the utility themselves installed another system. They maybe removed some of the pipes, which it's happening in the U.S. Northeast quite a bit. In the US, they're calling them thermal energy networks, TENS, but essentially, at least in New York State, the governor directed, I think, one of the utilities to actually install the system. In Massachusetts, I think it's Eversource. They did the same as a geothermal system. Instead of replacing leaky natural gas pipes, they decided just to not replace them and instead install a thermal network. So it's possible to replace one with the other, but it's generally not possible to, from what I've seen again, to use the pipes to transport a different medium. In this case, going from a gas to a liquid. Yeah.
I can add to that. I've sort of been looking at what's going on in the United States, and there are 11 states that have passed legislation allowing existing utilities to replace existing gas networks with thermal area networks. This is just getting going. And the key to it, there's a couple of really crucial things to this legislation, and it's all happening at the state level. So far, Trump has not been able to stop it so far. What they've done is they have appealed to labor because installing replacing gas networks with thermal networks is highly labor intensive. These are a lot of thousands and thousands of really good, well-paid jobs. And not only that, but the pipe that they use is exactly the same kind of pipe that gas uses. So even in the couple of pilots that are underway right now, the actual laying of the pipe seems to have been on time, on budget, because they already know how to do it. The other thing, and this is probably the real key, is they are allowing these existing utilities to use their rate base to finance. So there's no government finance involved. And the financing of the thermal area networks rolls out exactly the same way as if the utility was expanding the gas network, except it isn't gas. But it's just starting, and so far so good. I'll leave it at that. There's more. It's kind of been a thing for me. David McCauley?
Yes, thanks for the presentation. It's really good and very thorough. The one thing I've run into, having been in the business for a long time and renovated many buildings, is and I currently have a project underway just next door here, and we're having a hard time trying to recycle materials. And I know that in the past we used to be able to go to the dump, so to speak, and pick up materials there. Not too organized, but over the years, there's a lot of waste of materials that are being dumped and not recycled where they could be. And I'm thinking of some areas. I'm in the Kitchener-Waterloo, actually in Guelph, but there's a number of Mennonites and organizations that recycle materials. They'll build whole buildings and recycle and move buildings, things like that. And those practices just seem to have been lost. And maybe for environmental reasons, or maybe safety reasons, or not liability for whatever reason. But it seems to me that there should be a lot better use of things. There used to be the Teppermans and things like that we could go to and pick up materials that were either cleaned, recycled, or surplus materials from new sites. So I'm just wondering, how we can instigate more use of materials that go to waste.
Gail, did you want to answer that? Or?
Well, I think we need. I think that we need to get some government input or funding to promote the growth of these companies that would be involved in the demolition or picking up renovated waste. There's money in it, but as a startup, it requires money to start up a new company. But I think they really need to be nurtured. It would be brand new. It would be a brand new set of companies that would do that, and they can be very local. They should be very local. And this is, promoting small businesses. So I don't know, I think there needs to be some funding and some government initiative to get them going.
Yeah, so the first what we're trying to do right now is create the demand for recycled products by essentially if we have successful pilots, and in theory we could take the Vancouver or Victoria approach, for example, where they require deconstruction of older homes, like I think pre-1940, you have to deconstruct because there's good value timber in there. If we can get to that approach where essentially we're trying to level the playing field with traditional demolition, which is far too cheap. So you either make it expensive or, which won't work for everything because we only collect about 50% of CRD waste in Toronto. The rest is privately disposed of, and we have no idea what happens to it. So you either make it more expensive or you essentially do it by proxy, by regulation. So we have to first create the demand, but then the follow-up to that is we have to help create the market. So there are places, primarily on the west coast of the United States, I think Oregon, Washington, where they have like resource hubs where they've started organically and groups have gotten together to create these locations where you can actually have a market of used materials, which we're not even close to there yet in Toronto, because again, why would you do that unless you needed those used materials, which right now you don't need, or they're too expensive. And so to get there though, eventually we need to basically have these hubs available where materials can be stored and accessed. Those places actually exist already at a lot of demolition contractor yards. They're not doing it though for environmental reasons. They're doing it because those materials have value. And so we have to have the same kind of thing, but it has to be addressed differently because we're trying to get at it for environmental reasons, and there's a cost premium to that. And so that's kind of the challenge we face right now, is creating that market.
Don.
Sorry, Holly Kirkconnell? You have a question if you'd like to unmute yourself and ask your question? Or else I can read it. I have from Holly, thermal seems like a better way to go. My next door neighbors installed a heat pump last summer that blows hot air directly into our small outdoor area, making it unusable. Comments?
Yeah, I don't have a good solution for that one. I mean, yeah, it's definitely going to blow hot air in the summer. There's nothing you can do about that. I guess you could try to direct. I mean, yeah, try to direct that away from your outdoor area with some kind of baffle. I don't know. That's tricky.
Tricky, yeah. Holly asked one other question. Her old fourplex uses hot water radiators and a gas boiler, and she asked, "Can this be converted?"
Yeah, absolutely. I mean, there are electric boilers that, would be a straight swap. That may not be the best way to go due to cost. Electric boilers can be expensive to run. There are higher temperature heat pumps that are starting to become available. And they're not the kind you would typically just go to a contractor and ask for. These would be more engineered solutions that you would need. But they do exist, and there are precedents in Toronto from larger buildings where air source heat pumps have been used to replace hydronic heating equipment. So it is entirely possible. There are other options as well. The ground source heating and cooling can be retrofitted in some cases. So yes, there are replacements, but in that case, you'll definitely need like an engineered solution. If it's a larger building, a fourplex, you might be able to work with one of the providers. But I would suggest, at least speaking with consultants to help guide you through that process, because it can be a little more complicated than just a single unit house.
The other thing I'm just going to mention, if I might, if you go electric with, say, in a fourplex, that could require a significant upgrade in your distribution panel. And so you may have to go from, if it's a 100 amp panel, or 125 amp panel right now, you'll be stuck with at least going to a 200 amp panel, and that would be in the $5,000 range, and then that's with installation and wiring. But you may have to go to a 400 amp panel, and price of electricity is something to think about.
Yeah.
Versus what you're using now.
And the big challenge with 400 amp service in Toronto is Toronto Hydro is not allowed to deliver that overhead. And so trenching costs, if you have to cross any streets, it can quickly get very, very expensive. So you might get away with 200 amps for a fourplex. If you add even probably one electric vehicle, you're likely over the threshold. So it's really, you're on that edge there.
Norman has a question saying that thermal sounds great. Who are the competitors? And I wonder if I might expand that question a little bit to ask if there are any companies that are looking at bringing thermal area networks to existing communities. Has there been interest, Enwave or others? Anybody looking at that?
There's always it's always considered as part of any. So first they'll start with new development, but if there are existing buildings in the area, they'll be evaluated. It's unlikely you'd start with a pure retrofit. However, this is obviously pre building emissions performance standards. There may be scenarios where in certain areas it could actually make sense to do just a purely a retrofit. It's challenging, of course, like any retrofit, but especially with district energy because many buildings are fed from the roof, which means you have to run pipes all through the building. It can be very complicated construction logistics, but in theory, it's possible given the right economics. So yes, they will look at it, but as it stands today, you would likely need some kind of subsidy in the form of like an upfront grant or some kind of ongoing subsidy.
And Nick DiCarlo has a question very much related to that, asking if the city is considering its own corporation that, along with new housing, would build district energy systems.
Yeah, it's very topical today. What I can say, we've been given the direction a few years ago before we decided working with Enwave that we're not going to be in that business. But of course, that was a different council, and priorities can change. And it's possible that new council could feel differently in terms of the city actually taking perhaps an ownership role or a regulatory role in lieu of, let's say, provincial regulation. There are options basically we could look at where we're more active in this space and not just basically enabling private sector projects. But it would be premature for me to say anything conclusive. But it's definitely something we're thinking about because we know that we need to scale up district to help decarbonize. The question is the current model enough to achieve our goals, or do we need to be more active as a city?
Thanks. Karen, you have another question?
Thank you. Yeah, I just had a question about something I heard is out in the horizon, which is a minus 51 degree heat pump. I've got this house in Winnipeg and it does get quite cold. The current model maybe goes cold climate, maybe down to minus 31 is what I've heard, but I'm sure, for Northern Ontario, such a heat pump might be of greater interest to defossilize. So I don't know. I mean, it could be expensive, but I don't think it would be as expensive, or would it, as going directly into, say, a geothermal system, which could be quite expensive, about twice as much as was described for the cold climate heat pump that was put in by our guest. So I'm just curious, but also, I guess, looking into the future, here are people spending so much money on these heat pumps, cold climate and otherwise. At some point, there may be district energy coming. And it seems like a bit of a waste to be doing all this individually when it could be done on a more community-based level and amortized a bit. However, I don't see the two coming together. It is a problem in itself, but are there, any hopes on the horizon that we might soon see more district energy and not have to think so much about spending a lot of money on heat pumps? Thank you. And thank you for this presentation. It's been really great. Thank you so much, everyone.
Mike?
Oh, yes. I wondered, so in Toronto, some of the areas of apartment clusters are low income neighborhoods like St. Jamestown or Jane and Finch, and often they're privately owned buildings and without air conditioning, and create also a major adaptation problem. And I'm just wondering if there's been any consideration of the interaction between adaptation and decarbonization in those environments, and what the public role might be for that.
So, Mike, definitely I'll answer your question, and then I just want to make sure maybe go back to Karen's. I think I'll come back to it. Yes, but Mike, but not with respect to district energy. The city right now, we've been directed by council to work on I think it's basically a program to cool older apartment buildings, those without air conditioning. I think it's going to turn into basically a heat pump program. So basically, instead of just adding, let's say, typical window units, you can install a heat pump, and that means that it can allow you to both fuel switch the heating side and provide cooling at the same time. Now, it's much more complicated than I'm making it sound. Of course, any retrofit is, but that's the extent to which right now I've seen sort of an overlap between mitigation and adaptation. Now, district could do the same. It's just that there's no specific program to do that at this point. We're thinking more building by building, but it's entirely possible. And then Karen had asked about the two worlds coming together. Yeah, like I think there's definitely an opportunity for small scale systems to emerge. It won't happen organically. To my point earlier, this has to be, I think, a regulated space. Either has to be regulated in the same way as electricity and gas, or there has to be government direction to do these things, provincial government direction, as the equivalent of what the states were doing in parts of the U.S. As Don pointed out. It won't happen on its own just because the economics don't work today. The investment required to do a thermal network, just for most people, wouldn't make sense. For businesses, wouldn't make sense with the terms they currently have. I think we need longer amortizations and basically utility type models to make that work. And so that's something we're cognizant of. But again, so far the OEB has declined to regulate this space. I think it's probably closer than it has been in the past. They know that, they don't know, but when the OEB declined Enbridge's last rate case, their case, when they reduced the amortization period to 0, even though the government overturned that sent a strong message that perhaps at some point they are thinking about the gas utility death spiral, and if they don't get ahead of this, if they don't start thinking about how to enable the energy transition, it could leave a lot of people who don't have an alternative holding the bag, and that's a real problem. And so I think one way or another it's coming. I just can't say when. Yeah.
Thank you so much.
Norman?
Yeah, I just have a quick kind of follow-up on that. I did read very carefully the OEB decision that reduced. They were worried about death spiral. It was overturned by the provincial government in legislation. At least we think it is. I don't know whether that legislation has been passed.
Yes.
But my question is, and maybe you can't answer it, it just seems very reasonable to me that the OEB should be regulating thermal networks for two reasons. First of all, it would enable amortization over the period that you're talking about. And secondly, they are the regulator, and their primary responsibility is to protect customers and to ensure that they're not being kind of exploited by people who have quasi-monopolistic power over the energy that they receive. So my question is briefly, why is the OEB declining this? It just seems like a natural thing for them to be involved in.
Yeah, it's hard for me to give a specific reason why they've declined it, because they declined Enbridge's specific request to make it part of their regulated business in the past. So it wasn't necessarily that they said we will never regulate this space. It was just when Enbridge put in a request, they denied it. I think part of it is in fact because there is now a healthy market for private providers. It doesn't address your concern about consumer protection, but the OEB's challenge has become one of how do they do this in a way that doesn't essentially eliminate all those businesses that have started up to provide geothermal and wastewater and district energy services, because essentially you could only really have the idea with regulating it is as having a monopoly provider. How do you do that in a way that doesn't eliminate this healthy market? That's I think where they're at today, which I guess is a good problem to have, but problem nonetheless.
Right. Okay. Thank you.
May I ask something about this as well then? It's kind of a two-part question. One question that comes to mind, it's sort of an obvious thing is, well, where's Toronto Water in all of this? But the other question is healthy market. My understanding is that there are kind of two markets. One of the markets is large buildings of all types, where you have basically one client or maybe two or three large clients, but that's one kind of business. And then there's everything else, which is existing buildings, and perhaps the greatest challenge, existing neighborhoods, which is probably the greatest source of GHGs and perhaps the greatest number of individuals who would benefit by moving from gas to networks rather than heat pump by very slowly heat pumps. And that's a far more complicated market with lots of very small, delicate moving parts, if you will, just bill collection alone. And I'm not sure that there is a healthy market there.
Mm-hmm. Yeah, the market I'm referring to is large buildings. There is no thermal energy market for the scale you're describing. Again, the economics aren't there, so there's no market. So,
that's why I asked about Toronto Water.
Yeah, they're right now, our work with them is they're enabling like the wastewater energy projects, so they own that infrastructure. But if you're asking about like, could the city set up a division that's responsible for
a new utility?
It's possible, but that wouldn't. So the thing is like, yes, it's possible, but that requires a lot of political will, because that's something that it's a service on the tax base. Which would raise a lot of questions, right? Now, nobody questions the need for water supply and wastewater collection and treatment, but the district energy, we'd have to make a strong case as to why the city needs to be providing this as a service. So it's a fair comment, and that is one model. There are other models, but one could be as a city division. Yeah.
So perhaps a longer conversation.
Yeah.
Okay.
Anyway,
I wanted to.
I want to just interject a little bit with the split system, 1 ton and a 2 ton heat pump system. A ton is 12,000 BTUs. A kilowatt, just for reference, 1 kilowatt is the rate of expending energy, and that is equal to 3,413 or 14 BTUs per hour. And those are the figures that heat pump people, the the dealers will use and say, okay, you need a 3-ton unit. It could be a split 1-ton and a 2-ton. So in the spring and the fall, the 1-ton unit would work. And then the controls, as it gets either hotter or colder, will kick out the 1-ton and kick in the 2-ton. And then on the hottest days, you'll have all 3 tons working for you. And on the coldest days as well, you'll have all 3 tons working for you.
Okay. I think now is a good time to end the formal part of this, and we'll move to the after chart, but after event. Before we end, we'd like to thank Helen Hegedus, who's been handling the tech aspect and much else. And we'd also like to thank our speakers today for introducing us to this complex topic so well. And thank everyone for attending. Our next section will be on Monday, May the 5th at 2 p.m. And that will have Rachel Gilbert and Shoshanna Saxe presenting. And you'll be receiving the link for that session later this week, along with a short annotated biography of further reading if you would like to learn more. We'll now end the recording of this session,